Throughout this presentation, I'll be talking about the various biomechanical aspects of the closed zero movement skill of rock climbing. The biomechanical factors which this video will analyse is stability, force, motion and levers. Firstly, the climber utilises stability. As seen, a wide base, 3-point contact, core strength and wide grips and footholds help the climber to maintain their centre of gravity, which in turn creates stability. On top of this, the redistributing weight between hands, feet and holds places the climber above their COG, which is constantly moving and rotating throughout the climb. Leaning towards the wall and maintaining their hips near to it also helps the climber balance and control their movements. Furthermore, the climber uses their COG to gain momentum and conduct dynamic and explosive movements. Their body's movements are guided by their COG trajectory, and when reaching for far grips, he manages his COG by extending his opposite arm or leg to balance. These techniques help the climber stay stable on difficult climbs. Climber forces can also be examined. The climber generates and maintains sufficient grip on the rock surface to support their weight and propel themselves upwards. The climber optimises his hand positions and contact area to maximise friction between their skin and the rock. This allows them to maintain their hold and distribute their weight. The climber also applies appropriate force to each limb to create tension and leverage, assisting weight transfer. Generating force is also essential for upward movements. The climber utilises muscle groups and joint movements to generate force against the rock. They use pushing and pulling motions, leg drive and core engagement to generate upward and lateral forces, allowing them to progress on the climbing route. The climber generates momentum using body position. Through doing this, the climber conserves energy because of the synchronizing and transferring of motions and momentum. An example is shown through backstepping. This twists the body and provides rational forces and momentum to propel the climber higher or reposition them for the next movement. To grasp distant grips or overcome tough areas, controlled hops or lunges are also used. The climber launches dynamically and controllably using the stretch reflex and elasticity of muscles and tendons to help transfer movement. Finally, the climber employs levers. This is done by applying force away from the fulcrum and toward the rock holds. The climber leverages the rock and maintains a strong grip with minimal effort by carefully situating their hands and fingers on the hold. The climber also extends their arms and legs while pressing on a hold to increase lever arms and mechanical advantage, making it easier to stay put. Climbers also use counterbalances as depicted. Extending or counterbalancing the body in one way creates a lever and opposing force that helps climbers build momentum or bridge gaps on dynamic or reach-intensive routes. Flagging and stemming, for example, steady the climber. This is where the climber uses a lever system to balance their weight by pressing one foot or leg against a hold or wall to provide opposite force. This helps climbers balance, rebalance, and generate force. By incorporating and combining these biomechanical aspects into climbing techniques, rock climbers can enhance their performance, increase efficiency, and overcome the challenges presented by the vertical environment.